Component form of a vector. The directed line segment, whose initial point is the origin, is often the most convenient representative of a set of equivalent directed line segments. This representative of the vector v is in standard position. A vector whose initial point is the origin 0, 0 can be uniquely represented by the coordinates of its terminal point, v1, v2. This is the component form of a vector v, written as v equals, notice these special symbols, they kind of look like parentheses, but with this real rigid triangular look, angular look. So v1, v2. So what does this look like? Well, in the previous example, we took a look at this vector here, vector u, and it was the directed line segment PQ. Notice that its initial point is at the origin at 0, 0, and then it goes out. And it goes out to this terminal point. In this case, it's the point 3, 2. These two numbers here, the 3 and the 2, are the v1 and the v2, from our definition here. So the way we could write this is v is equal to 3, 2. And so that's what they're talking about. And these are called this is called the component form of the vector. The component form of the vector. Also, this is called standard position. You'll notice that through the year we've used standard position in different ways and talking about angles on the unit circle. And in every single case, we've had it where the initial point starts at the origin. So that's an easy way to remember this. Now the coordinates v1 and v2 are the components of v. If the magnitude of the vector is equal to 1, then it's called the unit vector. If both the initial point and the terminal point lie at the origin, then v is the 0 vector. So these are two important ones that you'll see a little bit later. They're going to be used in other definitions. The unit vector, this is a vector with a magnitude of 1, and the 0 vector, a vector that is, it has a length of 0, and it has an initial point and a terminal point at the origin. And this box here summarizes what we've talked about kind of nicely. Component form of a vector, the component form of the vector with an initial point P, P1, P2, and a terminal point Q, Q1, Q2, is given by this notation. The directed line segment PQ is equal to Q1 minus P1 and Q2 minus P2. And this will give us our V1 and V2, which is our vector. The magnitude of this vector V, or the length of it, is again this notation, and it's given by the distance formula. You'll notice that this is think of this as our change in the x's. This is the change in our y's, and that is the familiar distance formula. We know that Q1 minus P1 is V1, so they give you that shortened form. This part here, and this here are equivalent, and then this here and this here are equivalent. So these are just different ways of showing the magnitude of the vector. We said that if the magnitude of a vector is equal to 1, then we call v the unit vector, And if the magnitude of the vector is equal to 0, we call this the 0 vector. Now, going back to example 1. In example 1, remember we had that directed line segment PQ, where P was at the origin, and Q was the terminal point, so 3, 2. And so in order to find our vector, to write it in its component form, we would take the difference in the x's, the difference in the y's, and that's how we get our components. Now, we had two vectors in example 1. The other vector was from R to S. And again, notice that if we take the difference in the x's, the difference in the y's, 4 minus 1 is 3, 4 minus 2 is 2. Notice that these are equivalent to each other.